2 H even of Z now, okay? R of Z and are there any questions so far? From here to here, is using the first identification. So let's call this number 1, number 2, number 3. Right? Let's compare the cost right now. Suppose H have order 10, order 9, 9, 10. An example. Okay? For every output here, how many multiplication do I need to compute the convolution? Think of this. This has 10 coefficients inside here. How many multiplications do I need for each output coefficient? 10, right? Because what you do is you flip, multiply, and should multiply. So for every convolution point that's going to be one to have here, you need to do 10. So we have 10 multiplication per unit input. Okay? So there are 10 multiplication for every input point, unit time. You have 10 multiplication. Okay? And you have 9 add. But that's add is cheap, okay? Multiplication is more expensive. Look at this form here. What is how many coefficients in each even? 5. We are taking 10 numbers, right? You distribute to 5 and 5. So each of this have 5 coefficients. Is that clear? How do you have to do it for every time? Or is it different? So let's see what happened over here, right? To figure out whether you have to do it every time or not. To figure out what's going on with input X and going to the block. So tell me the operation that we have there. What happened when a string of number going through this? So let's look at cause, okay? When X of 0 goes through. This branch or that branch? Top branch, right? X of 0. And then at that time, this is 0, right? X1 come in. Where does X1 go? Does it go down here or up here? Down here. Because this delay. Okay? So X1 go there. Where does X2 go? Up. X3, X4, X5, and so on. Again, what is that? That is serial to parallel buffer, right? Basically, you just block the input. You just form a string number coming in, just form a vector, right? And there's no cost there. We never implement downsampling as it is. We implement it as just blocking, right? A string of number coming in, you just block it to get a vector representation. Okay? So when do we have to do this operation? Do we have to do it every time it's coming in here? Or we do it every other time, every 2 times? 2 times, right? Because it takes 2 unit time to form a vector. Right? You have x0, 0, and x2, x2, x1, and so on. So it is 2 times. So this operation, 5 multiplication per 2 unit time. Okay? This one, same. 5 multiplication per 2 unit time. Combine, what do you get? 5 multiplication per unit time. It's half. That's what we want. We want somehow not to waste the computation. We don't want to compute and throw away information. We want to do it just right. In other words, saving a factor of 2. Right? Instead of doing 10 multiply and then throw away the other 5. Well, doing a vector processing right now. Right? To get 5 per unit time. Okay? So right now, polyphase is what we use in Modulation. So if you open up a JPEG encoder or Wavelet encoder, we never implement it like this. You see polyphase in there. Okay? You see there's a blocking. We go from 0 to parallel, and you see there's a parallel multiplication. Always the case in the chips or in the software that they sell. Okay? Any questions here? Is that clear? So let me start the question.
What is phase in this?
Phase?
Yes.
Well, you don't really care about the phase, they're equivalent. Right? Because what you see here is if X is here, Y is there. This is a unique representation. Equivalent and unique. These have the same X and Y coming out. Oh, polyphase. Poly is many. Okay? Many phase. You can show that. Okay, you can show that if you take a phase here, you can actually split down to 2 different phases. Okay? If you're interested, I can send you papers on the properties of phase. Basically, poly is many. You have one phase to split down to several different phases. Okay? So let me, alright. Can I erase this? Okay. The next thing I'm going to do is, so this is in the analysis, right? In the synthesis, you have the opposite, right? You have a filter by upsampling and filter. F naught. Again, this is not efficient to implement. Why? Because you increase the rate and you filter. Even the 0 in there, but you still have to increase the rate. So this filter has to operate at a high rate. Right? It's not good. You want to move this upsampling to this side. Similar to, you want to move this downsampling to the other side. So in this case, I want to use a second noble entity to move this block to this side. I'm going to skip all the operations. The result is going to be like this. So the steps are taking F naught and write it in this form. F even, F odd. Okay? So what you have will be as F. You have F even of Z, F odd of Z, up by 2, and okay, from here to here involve polyphase